Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz,
And this is Mrs. Weichel.
and we are looking at 9.3 density. What will you be learning? Well, by the end of class, you will be able to find the density of different shapes and, I know it doesn't make sense, places.
Very
Shapes and
cool.
places. So, why do you need to learn this? Well, you need to know this because density affects whether objects will float or sink. Well, that's like buoyancy, right?
I love that word.
I do
That's
too.
a fun word to say.
It is.
Buoyancy.
It is buoyancy is very important. It is an important property to consider when building things like ships or hot air balloons because they both need to float.
So our naval fleet better know their density properties.
Something, I'm telling you. And then population density of an area can be one of the most important determining factors for business and marketing planning. So those of you who are taking marketing, you might want to understand
We're
population
interested
density.
in opening your own business someday.
Yes, absolutely. Well, how will you know you know it? Well, you will know that you know this well when you can determine how many people live in an area or the density of an object.
Very cool. All right, let's go ahead and get started with some vocabulary terms. What is density? It is the measure of how much mass is in a certain amount of volume. So we're going to be comparing two different things together to find our density. What is mass? Mass is the measure of how much matter an object contains. So a lot of you probably think of science when you do stuff like this, and you do frequently talk about mass in science. It is often confused with weight, which is caused by gravity. So you've probably done this maybe in like a science museum, like what would your weight on the moon be? Like the gravitational pull in the moon is less than here, so you weigh less on the moon. However, your body composition is not changing. Your mass is not changing. So your mass is actually a more true representation of you.
Yeah, so you should stop telling people that you're watching your weight because you're not. You're watching your mass.
Yep. And then lastly, we all know, hopefully by now, what volume is. It's the amount of three-dimensional space an object takes up.
Perfect.
All right, so you guys have this triangle on your paper if you're taking guided notes. If you are not, please draw this on your own paper. This is kind of a way for you to remember three different formulas all at the same time with the relationships between density, mass, and volume. So if you are looking for volume, if you look right here, we have DMV. You want to remember this triangle, DMV. If you are looking for volume, volume is found by taking the mass and dividing it by the density. So you guys have a volume triangle. You can go ahead and fill in the blanks, please. The volume, again, is the amount of space in cubic units that an object or substance occupies. And again, it is found by taking the mass and dividing it by the density. If you need to pause, please pause if you're not done writing. If you are looking for density, density is found if we cover up this the D right here in our DMV triangle, you're left with mass divided by volume. So we know that density, which is the amount of mass per unit of volume of a substance or object, is found by taking by taking the mass and dividing it by its volume. So go ahead and fill in the triangle for density. And then lastly, if you're looking for your mass, which is down at the bottom, if you cover up the M in that middle triangle, you're left with that D and V right next to each other. So we are going to put a multiplication sign between them. So mass is calculated by taking an object's density and multiplying to its volume. And again, mass is the amount of matter an object has. Mass is equal to D times V. So when you're doing these, you should end up on your paper with this. So you can see all three here. I just blew them up for you a moment ago. Make sure you have your symbols in here so you know which operation you're going to be doing. And when you're working with these, you should be given two of them and you're finding a third. So it should be clear what you're plugging in for what and what you're solving for what. So make sure you get this written down, please. All right. And then that is taking us to the next side where we're going to actually be solving some density problems.
Now, if you're using your guided notes, I have to apologize because I accidentally put the the borders in your triangle upside down, so you can either white them out or kind of scribble them out, maybe draw yourself a new triangle. But the triangle at the top right of your page, you are to fill in the M over D and then V, just like we have in our picture here.
So if you remember the way we were talking, if you're looking for volume, if you cover that up, you can see mass is over density. So you would divide mass by density, which is what we just talked about. If you're looking for mass, well, that puts D and V right next to each other, so multiplication. And if you're looking for density, it's going to be mass divided by volume. So if we go ahead and read this problem, you are given that you have 10 cubic centimeters of a sample of copper that has a mass of 89.6 grams. The G is grams. What is the density of the copper? So looking at, again, similar to what we did in our last lesson, these are similar to word problems, so you really have to read the clues and what we're telling you to use and what we're asking you to find. So we are given a volume of 10 and a mass of 89.6, and you're asked to find the density. So we know that density is found by taking the mass and dividing it by volume. And you can again see that from our little visual triangle here, M is over V, so we're going to divide them. Here's where it's just super easy. You're going to plug in the mass, plug in the volume. So we have 89.6 divided by 10, which I hope you can all do without a calculator. And you just get 8.96 grams per centimeter cubed, and that is your density of this sample of copper.
Yay!
All right, next, we know that silver has a density of 10.5 grams per centimeter cube, and gold has a density of 19.3 grams per centimeter cube. Which would have a greater mass, 5 centimeters cubed of silver or 5 centimeters cubed of gold? So we have to find our masses. So looking at what we know the density of silver is 10.5 grams per centimeter cubed, and we are using a volume for silver of 5 centimeters cubed. Our gold, we know that the density is 19.3 grams per centimeter cubed, and our volume that we are using is 5 centimeters cubed. To find the mass, because we're comparing masses, you're going to cover the M up, and we're going to use D and V, which are right next to each other, so you're going to multiply. So the first thing we do is multiply for our silver. The next we're going to do is multiply for our gold. So we're plugging in 10.5 and 5 and 19.3 and 5. That gives us a mass of 52.5 grams for silver and a mass of 96.5 grams for gold. So comparing the two numbers, the question is which would have the greater mass. We would say that gold would have the greater mass because it is 96.5 versus the 52.5.
So these problems look very complicated, but they're actually very, very simple. Some of the easier problems we have ever done, because you're always just literally multiplying numbers or dividing numbers, having your calculator do it. The biggest trick to these is sometimes they'll give you the dimensions of an object and you'll have to find the volume.
Yep.
But
which
that's really,
we went over in 9.1.
which is really, that's as hard as these get.
Yeah.
Speaking
of the devil,
which, we've got to find the volume.
There we go. So we have a sample of iron that has the same dimensions of 2 centimeters, 3 centimeters, and 2 centimeters. If the mass of this rectangular shaped object is 94 grams, what is the density of iron?
Okay, so we know that we have the mass, and we also know we have dimensions of an object that would give us volume. So we have mass, we really have volume.
Because you just multiply the depth, the length, and the height.
And sure enough, they're asking us to find the one thing we don't have, density.
The density. And if we look back at our little trusty triangle here, we know that density is found by dividing mass by volume. So we're going to plug in the mass of 94 and the volume we just calculated of 12. And then from here, you simply divide, and you get 7.83, and you have grams over centimeters cubed, so you would read this as the density is 7.83 grams per centimeter cubed.
Easy.
All right, moving on. We have a cylinder with a radius of 2 centimeters and a length of 7 centimeters. It has a density of 3.1 grams per centimeter cube. What is the mass? So again, we have a figure where I'm giving you dimensions. So the dimensions we can use to find the volume. The volume is the one thing that the dimensions will lean towards to help us find. We know the density is 3.1, and we know we are looking for the mass. So Mrs. Netz and I actually had a conversation about this. The length of the cylinder is 7 centimeters. If you think about what a cylinder looks like, Mrs. Netz explained this pretty good to me, actually. Just picture that it's laying on its side, basically. The length of this cylinder is the height of the cylinder. So that distance between the circles.
So if you think about it, the length of your bed is typically a little bit longer than your height.
Right.
So the length of this cylinder, so length and height they kind of go together.
So we know that to find the volume of a cylinder, it's pi r squared times h, where in this case r is going to be 2 and our h is 7. So if I plug that in, I get 28 pi for our exact volume of this cylinder. And our density is 3.1 grams. We're looking for mass. Well, mass is found by taking the density and multiplying it to the volume. Well, we're using a density of 3.1, and we're using a volume of 28 pi. So I have 28 pi times 3.1. That's going to give me approximately 207. I don't know why I have D here. That should be M. M is equal to, let's see if I can get it to fix. There we go. My bad. Whoops. The mass is approximately 272.69 grams.
Perfect.
All right, let's go ahead and turn the page. We are now going to talk about population density, which was one of the parts of our learning target, deciding how many people live in a specific area. So population density is the intensity of land use, or it tells you how crowded an area is on average. Population density is expressed as a number of people per square kilometer or square mile. Notice that now we're talking about square units. Well, square units is what we use when we find area. So the way I like to think of this is you live on land, you're not living in land, so you're finding the area, like where people would be standing, versus you're not climbing inside of an object like volume.
Yep.
I don't know how. I'm literally picturing like people, I don't know.
Living on land.
And it can help you figure out the resources that a certain area requires. So governments use this a lot. Your government census, I believe, that comes out every
and it, like we had mentioned in the beginning, if you're doing any type of business marketing and you want to know how many people are living in an area, like if you think about Japan is what we would say is very dense. There are a lot
of space, but a lot of people.
And if you think about the state of Nevada, it's not very dense.
Other than Las Vegas.
There's
Reno slightly.
There's just not very many people in the actual state.
Right.
So
even here in Arizona, we have a lot of vacant land.
I agree.
All right. So how do you find it? Well, you take the total number of people and you divide it by the land you're looking at. So if you're looking at, say, Phoenix, you would look at how many square miles Phoenix covers and then how many people live in that area. And then that's going to give you per square mile how many people or how dense Phoenix would be. And that's what we're going to start doing. So we're talking about a picnic blanket. That's 4 by 3 meters. And there are ants all over it.
You'll understand the laughter.
Okay.
Very
so
soon.
We want to know the population density at 3 p.m. Well, at 3 p.m., there's 45 ants. Well, this is similar to the problems for just regular density where we had to calculate the volume. Well, I didn't give you the area of this blanket, but I am telling you the dimensions. And it's clearly a rectangle here. So we would just simply take the total population, which is 45 ants, and we would divide it by 4 times 3 because 4 times 3 are the dimensions of the blanket.
Again, remember, people over area.
So we have 45 divided by 12, which works out to be on average 3.75 ants per meter squared. For part B, we're asked to do the same exact thing, except what is the population density at 5 p.m.? Well, if we read the problem, at 5 p.m. there are 85 ants. So we have 85 ants over the area of 4 times 3, which again we know is 12 meters squared. And 85 divided by 12 gives us a density of 7.08 ants per meter squared. And then the last part is asking us, at what rate is the population density increasing? So you're basically comparing the 7.08 to the 3.75. You would find the rate it's increasing by subtracting, and you find that on average, your rate is increasing by 3.33 ants per meter squared. All right, the next problem, we are talking about the state of Vermont. Currently, in the state of Vermont, there are just 626,299 people living there. Vermont's territory can be modeled by a trapezoid. So you can see in the picture here, the shaded gray figure here, it's not a perfect trapezoid, but you can see that by outlining it in this pink segments that you're basically forming a quadrilateral where the top and bottom are parallel to each other. That makes a trapezoid. Each unit on the coordinate grid represents 1 mile. So we're going to find the approximate population density of Vermont. So the first thing, we need to know how many people there are. Well, right here it's telling you that there are 626,299 people. The next thing you need to do is figure out what is the area of Vermont. Well, here is how you find the area of a trapezoid. If this is confusing, the other thing you can do is split this trapezoid up into a right triangle and rectangle. It's a composite figure.
A composite figure?
Yeah. So you could do that. This is yet another formula, and I know you've had a lot of formulas, so if it's too much, again, you can, from D, go straight up, and it forms a right triangle right here, and it leaves you with a rectangle over here. You should still be able to get to the right answer. So the height is going to be the perpendicular distance between your bases, and your bases are your parallel sides. So the top and bottom are the parallel sides. That's your B sub 1 and B sub 2. Your height is going to be the distance between them. So we have 160 for our height, if you count, and 80 and 40 for our bases. From here, you just simplify and you end up getting 9,600. So our area is about 9,600 square miles. So now we just do our population density. So the population divided by the area works out to be, on average, about 65 people per square mile. So that would be similar to, like in Arizona, we're pretty grid, like a grid layout. So like between 91st and 83rd and Deer Valley and Beardsley, is that the next one? 65 people live there. That's not very many people.
That's not very many people at all.
So they must have a lot of land, which makes sense because lots of farmland there. All right, moving on. Last problem about population density. According to the Census Bureau in the United States, there were 328,700,896 people, and the land area was 3,531,905 square miles in the United States.
Hey, this problem is different than the one we did last semester.
Because you updated the data.
Because I looked up the current numbers. Notice it's April 10th, 2019.
Yes.
This is not very long ago.
Yeah, I think we had like 2012 was our old data. Yeah.
We got some new info.
Cool. All right, so based on this data, I'm going to let them do it. I want to know what you find the population density to be.
And if you look on the screen here, it shows, because this is accurate data, how fast we are growing. You'll see that if we do the math, it looks like we should get somewhere close to 92.63 people per square mile. So that should be pretty close to what you get according to how we are growing.
So go ahead and pause it, find your population density, and see how close you are to what they are saying the density is. All right, so by now you should have come up with this fraction by doing your division here. And then that is approximately 93.1 people per square mile. So we came up with 93.1. They're saying 92.63.
6'3".
That's pretty darn close for, given we were talking millions of people versus millions of square miles, we're within one person, not even one person. So I think that's pretty cool.
I would say we're pretty accurate.
We're pretty accurate.
I would say the formula works.
I would say I agree with you. All right, turn the page. We should now, if you're using guided notes, be on page 26. The last thing we're looking at are BTUs.
BTUs?
British Thermal Unit.
Oh.
It is a unit of heat, and it is approximately the amount of energy needed to increase the temperature of 1 pound of water by just 1 degree Fahrenheit.
Oof.
Pretty neat. You may have seen BTUs. You see those on, I think, air conditioning units.
Yes.
I believe maybe refrigerators. I don't know.
Ooh.
Wherever there's temperature, I think. Yeah. So to find it, BTUs per cubic foot are found by taking the total BTUs and dividing it by the volume of the tank. All right, so here we go. We have a tank. It's filled with a gas, and it has the dimensions that is shown. So notice you're not told what you need, but you are given a diagram, and it is a shape that we have discussed before in this chapter. We are asked to find the BTUs produced by 1 cubic foot of gas when the tank is filled with natural gas. It provides 116,151 BTUs. Round to the nearest BTU. So we just wrote that BTUs are found by taking the total BTU and dividing it by the volume. Well, you're given the total right here. It's 116,151. We have to divide that by the volume of the tank. Well, our tank is this. If you look at the shape we're giving you, it is a sphere, and the sphere has a diameter of 6 feet. So we need to remember how to find the volume of a sphere. It's 4/3 pi r cubed. Well, 4/3 times 3 cubed. Well, 3 came from the fact that your radius would be half of 6. So 4/3 times 3 cubed gives us 36, and then we haven't touched the pi sign yet. Remember, we don't want to round too many times, so we're going to leave this exact while we can. So you get a volume of 36 pi cubic feet. So now you're going to take your total BTUs and divide it by 36 pi. When you plug that in your calculator, you get that there are 1,027 BTUs in this tank of natural gas.
Not too bad.
And last but not least, we're going to use the same exact tank, but this time we're filling it with kerosene. Kerosene provides about 114,206,000 BTUs. There we go. I was wanting to add numbers there. And again, we know the volume of this tank is 36 pi. So we're going to go ahead and find the BTUs of this situation. All right, you should have taken that 114,206,000 BTUs and divided it by that volume you found in the last problem, and found that we have 1,009,803 BTUs in this tank of kerosene. Thank you so much for joining us for density. Hopefully you feel confident that you could find the density using mass and volume, density for population given area, and then last but not least, our BTUs. If anything was confusing, as always, please don't forget to reach out to us as soon as you possibly can.
Hey, Mrs. Weichel.
Hey, what, Ms. Nutt?
Did you know that you can tell the gender of an ant by throwing it into water?
No, I did not know that.
If it sinks, it's a girl ant.
Okay.
If it floats, it's boy ant.
That's a good one. That might be the best one you've done.
So wait a minute. So all the ants on the picnic blanket, we can throw them all into the water, and the ones that float are buoyant.
That's so mean. I seriously, that's just cruel. I don't like it. All right, so Don't forget to like us on YouTube.
Smash that.
Smash the like button.
Smash
Is that
the
what you
like
say?
button, or hit it, or pop it, or snap it.
I was
or
asked to throw that out there, so
like us.
Just like us.
Like, hit some button.
Smash the thumbs up button.
Thumbs up us.
I
Like
don't know.
us.
We sound really bad.
Retweet us.
Oh man. All right, we have just one more lesson and then we're all done.
Oh, aren't you
Cheers.
so happy?
All right. Peace out.
Bye.